Welcome to the project demonstration of power quality monitoring and load controlling system. So here we are monitoring the voltage and the load which is connected at this section, monitoring on the 16:2 LCD display, as well as we are going to send the so-called parameters of voltage and the load details to the ThinkSpeak IoT platform with help of this ESP8266 module. So here the flow is, we are going to provide the 230 volts to this plug, and so here we are going to distributing the 230 volts to the load section and to this load section, as well as here to this CT. Sorry, this is the PT and this one is the CT. So from the PT we are going to step down the 230 volts AC to the 12 volts of AC, and from this regulated power supply board, so put a particular 12 volts of AC voltage will be converted to the 12 volts pulsating DC by using this bridge rectifier. 4 diodes are connected in bridge rectifier manner, and after that the pulses will be removed with help of this capacitor, and after that we'll get the voltage input to the 7805 regulator. So from this regulator we will get the constant of 5 volts regulated power supply, and there will be one LED indication on this board. So the 5 volts will be given as main power supply to this motherboard. So here we are using PIC16F73 microcontroller. So it will start reading the input from the CT and the PT. So the CT data will be given to this PIC16F73 microcontroller through this potential divider circuits. So here the connection is the 230 volts is connected given in series to this 3 devices. So like one is CT and a relay and a load. So these 3 are connected in series. Why? Because the relay is used to control this load, and the CT will measure the current when it is connected in series with the load only. And after this, the generated voltage will be given to this potential divider circuits. So why? Because we will get the AC signal here. The AC voltage will be stepped down by using this resistors, and after this rectifier DB107 is a rectifier. After this we will get the DC voltage, and again that will be stepped down using this potential divider of 10 kilo ohm in series. Why? Because a microcontroller need only 5 volts, so it can read up to 5 volts. If it is more than 5 volts, then it will make it damaged. In order to reduce the voltage, we are making use of this potential divider to make the CT output voltage finally below 5 volts. So and next, so here we place one more capacitor on this in order to convert into the pure DC, and this is the reset switch, and this is the capacitor. The purpose of this capacitor is whenever we get the 5 volts regulated power supply, so there may be chance of ripples in the regulated voltage. So in order to remove the ripples, we are making use of this capacitor, and this one is the power LED indication with 330 ohm resistor, and these 5 pins are the programming pins in order to load the program Xcode into this PIC16F73 microcontroller. Along with we are using of 20 megahertz of crystal oscillator. This is the 20 megahertz crystal oscillator, and one more LED is there. This is a program LED indication. Whenever we switch on the kit, the particular light will on and off 2 times. It is indicated the program got initialized and start executing the main program. And the connections are LCD is connected at B2 to B7, and ESP8266 module is connected at B0, B1 and C7 for this electromagnetic relay. And here LED is going to be the C4. Here coming to this relay board, so there is a one LED indication which indicate the relay status, as well as one transistor. So here the connect flow is microcontroller will trigger the transistor will trigger the relay, and the relay will trigger the bulb. So here the diode also will be present. So the diode purpose is whenever the relay is getting on and off, so as we know that the relay is nothing but is a copper winding inside that. So whenever it's getting on and off, it will generate the back EMF. So in order to neutralize the back EMF, we are making use of this reverse connected diode. Okay, and before switching on these kits in your phone, we need to enable the hotspot. So we need to enable the hotspot with the name of PROJECT, that is a project 4496 and a password 129, and then on the hotspot data kit. So here, in order to change your hotspot in your phone, just go to personal hotspot settings in your phone and change the name of the hotspot SSID to project without any space, without any capital letter. This is very important. You're not supposed to miss any single character also. And after enabling the hotspots, so then we need to switch on the kits, just disconnecting the bulb. So here the limitation of the load is So we set that for 80 watts. So now we are using 20 watts bulb and it's 100 watts bulb. So we set the load limit for the 80 watts only. So as I already enabled the hotspot in my phone from which I am taking the video, right? So there will be a welcome message on your screen. So we can see that there is a welcome message on your screen, and once it's got initialized, you can see the Wi-Fi module connected in your phone. So you can see that in connected device manager. So there you can see the ESP module. Now there is no load, so 0 watts, and the voltage is measured and displayed. And so just I'm connecting the normal load. So now it will be measured continuously and the load will be displayed on the LCD screen. Okay, and also we will get this same data into your ThinkSpeak. So now this particular data will be uploaded to the ThinkSpeak. So as we can see that the live data is uploading continuously into the ThinkSpeak cloud. Just log in to the thingspeak.com with credentials, and there we can see the live data. You can check the time also. Here the value as well as the timing will be uploaded continuously to our ThinkSpeak our account. And if we can download this also, like go to the data import and next download, and there we can get the CSV file. It will be there directly loaded into the Excel sheet, and we can see here the entry IDs and the total field 1, field 2, nothing but the current as well as the voltage parameters will be stored continuously along with the date and time details also. So in order to clear that, go to channel settings. If you want to erase the old data, then go to channel settings, and here only do clear channel. This is very important. Only do clear channel, don't do other things. And next, in this your account, just we need to access private view, channel settings, and data import export. That's it. And now go back to the private view. There we can see that the old data got erased, and now the new data will be appeared. So in the frequency of time around 10 to 15 seconds. So that it will plot the points. Right, now we got the new entry. So we can see this. Right, now we got the new entry and it will continuously uploading into this. So meanwhile, let us check the load controlling. So as till now we have seen the load measuring and power quality. So now we are going to controlling the load. Just I'm going to disconnect this bulb and placing the heavy load bulb. So whenever the load is increasing the above 80 watts, then automatically overload will be indicated on the LCD screen, as well as we are going to control the bulb by using this isolating the electromagnetic relay. So same data will be uploaded into our ThinkSpeak cloud platform. Right, so we got this voltage as well as the load details uploaded one. Right, thank you for watching. Down.